Good morning. I hope everyone's excited and strapped in. I have the great pleasure of inviting everyone in for science-related projects, experiments that will be hosted by our corporate partners, which include DuPont, Boeing, FMC, ILC Dover, and Elite Universal Network.
Hi, I'm Vicki Chang, and I'm a formulation scientist at FMC Stein Research Center based in Newark, Delaware. At FMC, we make products that farmers use to protect their crops so that they can grow enough food for us to eat. As a formulation scientist, I come up with a recipe that goes into the products that we make. So I'll make decisions like what ingredients we use and how much of them to put into the recipe. So in today's video, we'll be talking about this process called emulsification, which is important in my work, but also affects a lot of other products that you might find in your house, like milk or ice cream or lotions and hand creams. So you might have heard the saying that oil and water don't mix, and you might have actually seen it for yourself. In fact, if you look at these salad dressings here, both of them contain oil and vinegar, but one of them is separated and the other one is not. So why is this? It's because of a process called emulsification. If you look at this bottle, it contains a mixture of oil and water, which form two separate layers. So this oil and water mixture is a lot like the oil and vinegar mixture that you would see in a salad dressing. If you shake up this oil and water mixture, the oil will be broken down into small droplets, but it won't stay that way. It'll eventually separate out into separate layers again, unless if you use an ingredient called an emulsifier. An emulsifier is something that will stabilize an oil and water mixture and keep it from separating out. So why does an emulsifier work? Well, it contains both a water-loving or hydrophilic part and an oil-loving or lipophilic part. So it acts as a bridge between the oil and water, and it'll stabilize the oil droplets and keep the oil from separating out from the water. In today's experiment, we'll be working with some common ingredients that you have in your house and seeing which ones work as emulsifiers. If you downloaded our handout, it'll have a list of the materials you'll need for the experiment. If you don't have the handout, here's what you'll need: oil, vinegar or water, mustard, honey, mayonnaise. And if you don't have honey, mayonnaise, or mustard, you can use dish soap instead. Okay, great. Let's get ready to do our experiment. So now that you have your ingredients ready, what we'll also need are some clear containers or jars so that you can put your liquids in. So in these jars here, I've already measured out 2 tablespoons of oil and 1 tablespoon of vinegar. And then here I've measured out half a teaspoon each of the mayonnaise, mustard, and honey. So these 3 ingredients here are going to be the emulsifiers that we're going to be testing in the oil-vinegar mixtures. So I'll start by preparing what's known as the control, and I do that by just capping this jar here. Our control will not have anything added to it, and it'll be something that we compare the rest of our test samples to. Now I'll go ahead and add the mayonnaise to this jar. So I know the mayonnaise can be a little bit tricky to get out, so don't worry if you can't get it all off of your spoon. It's totally fine for this experiment. Though I have to add, when I'm doing my experiments in the lab, I have to be very precise. So I do make careful notes in my notebook of what I do add to my recipes. So go ahead and label your jar, and then we'll go ahead and cap it. Now I'll do the same for the mustard. Try to get that in there. And then make sure you cap your lids fairly tightly. And then last, we'll go ahead and add the honey to this jar here. And then help if you put that in there. Okay. So now we're ready to make our emulsions. Okay. Make sure that the jars are ready and capped tight, and we'll go ahead and we start by shaking up our samples. So you emulsify things by shaking, and we'll want to shake for about the same amount of time for each of these samples. So count to 10 for each of these, and then go ahead and set it down. So you want to shake it as hard as you can for about 10 seconds, and then set it down. We'll do the same for all of these jars. So that's it. You've made your emulsions. And what we'll want to do now is we will go ahead and come back in 5, 15, 30, and 45 minutes and check on our jars and see what the samples look like, because we'll be testing our emulsifiers and seeing which ones work the best. Okay, so we're 5 minutes in, and let's take a look at our emulsions and see how they're doing. It looks like our control sample is already starting to separate along with the honey mixture, but it looks like the mustard and the mayonnaise are still pretty stable and not separated quite yet. So let's go ahead and wait for another 10 minutes and check back in again. All right, so we're 15 minutes in. It looks like the honey mixture is about as separated as the control, but it looks like the mustard and mayonnaise mixtures are still going strong. So let's check back in another 15 minutes and see where we're at. Okay, so we're at the 30-minute mark now. Let's see what our samples look like. It looks like we have a new development. So our honey and control are still separated, but it looks like the mustard mixture has also separated now, which makes mayonnaise the clear winner. It looks like mayonnaise works the best as an emulsifier in our vinegar and oil mixtures. So I wonder why that is. Maybe we can take a look at the ingredients in mayonnaise and see what it has. So it looks like mayonnaise has soybean oil, water, whole eggs, and egg yolks. So egg yolks contain this compound called lecithin, which are a known naturally occurring emulsifier that works really great for stabilizing foods. So with this mayonnaise emulsion that we have here, we have a really great base for a basic salad dressing, but you'll notice that we didn't add any seasonings to it, so I don't know how great the salad dressing might taste. So you might want to experiment a little bit with what kind of spices or seasonings you might want to add into your salad dressing. So while you're making additions with your spice mixtures, you might want to keep notes of what you put into your dressing so that if you find something you really like, you can really easily recreate it. This process is pretty similar to what I go through when I'm developing recipes at FMC. I'll make an experimental formulation, I'll test it out, and then try and do some experiments where I add some extra ingredients or take some out and continue to test them so I can figure out a recipe that I really like. So that's the end of our experiment today. So let's wrap up by summarizing what we've learned. An emulsion is a mixture of liquids that don't normally mix with one another, like oil and water. An emulsion is stabilized by an emulsifier, which contains a hydrophilic or water-loving portion, as well as a lipophilic or oil-loving portion. And the emulsifier acts as a bridge between the oil and water components in the mixture. So before you go, let me tell you a little bit more about FMC Stein Research Center here in Delaware. We have all sorts of STEM fields represented. Our biologists work in the greenhouse, we have engineers working out on process chemistry, and we have statisticians helping us out with our data analysis. And you know me, I'm a chemical engineer working as a formulation scientist. So in the lab, I work on a type of product called an emulsifiable concentrate, and it contains our novel chemistry along with an oil and some emulsifiers, all packaged into one product. Now this product looks like a clear solution, but when you add it into water, it instantly forms an emulsion. This is exactly how a farmer applies our product. They'll take our product, weigh it out, and then they'll add it to a spray tank full of water, and the emulsifier stabilizes the mixture while they're spraying out on the field. Not bad. So if you enjoyed today's experiment and think it would be fun to make different products, I encourage you to consider a career in science. You could have a huge impact on society. You could develop vaccines, help the environment, or develop new technologies. The possibilities are endless. And the next time you make a salad, you can also impress your family and friends by explaining the science behind the dressing. I hope you enjoyed today's video. Thanks for watching.